Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video and next few videos is dedicated to parametric curves or parametric equations and what are known as planar curves, which are the curves represented by parametric equations. So this is usually, in my opinion, something that belongs in a trigonometry course. However, at our college, we don't teach it on a trig course, we teach it in our pre-calculus course. You should be learning it, hopefully, in a full trigonometry course. It is very important for calculus, specifically Calc 2 and Calc 3. It is incredibly beautiful as a topic. So let's go ahead and delve into here the concept of what a set of parametric equations is and what a parametric or a plane curve is. So parametric equations are essentially like an Etch-a-Sketch. The left knob on an Etch-a-Sketch that you can see right here controls the horizontal movement or the x-axis. And the right knob, which you see right here, controls the vertical movement or the y-axis movement. So one knob, the left, represents a function x of time. As time moves on, you're wiggling things left and right. The right knob represents also a function of time, but only the vertical values that you're graphing as a function of time. And this artist here is sketching Michael Jordan using his Etch-a-Sketch and parametric curves. This is also known, by the way, the equations themselves are known as parametric equations. The curve that you graph out is known as a plane curve, but I still call them, and most people do, call them parametric curves. But an Etch-a-Sketch is a beautiful way of visualizing how parametric equations are used to graph. So the definition here, if f and g are functions of t defined on an interval I, so time is defined on that interval I, then the set of points f of t comma g of t is called a plane curve. The equations x, which is the function f of t, and y, which is the function g of t, where t is an element of the interval I, are called parametric equations for the curve with parameter t. Parametric equations, as you can see right here, and plane curves are essential in calculus, specifically Calc 2. So you will encounter them at the middle or end of Calc 2 and then see them throughout Calculus 3. They are very, very beautiful curves. They're also kind of fun to play with, but incredibly difficult to graph by hand. This does not mean that you can't graph some of them by hand, and generally textbook examples are the ones that you can graph easily by hand, but the vast majority of parametric equations cannot be graphed easily by hand. So we're going to go ahead and start here with a set of parametric equations, one representing the x values and one representing the y values. By the way, some people will write this instead as x of t is equal to 2t. That's because x is a function of t, and y of t is equal to t plus 6. That's perfectly fine. There's nothing wrong with that. And in this case, one of the very few moments where we're going to graph something by building a table. Normally, I don't like using tables of values to graph. However, in this case, because we're just learning something very new to us, it is important to at least take our time with it. So let's build a table of values. We do this by having x versus y, but before that, almost alphabetical order, right? We have t. And so we're going to select values of time, t, and then determine what the x and y values are for that time. So I recommend selecting probably 5 or more time values. It just depends. There's no rule of thumb, and normally you would never really plot out a table of points like this. This is more for an elementary algebra idea. That's what you did in elementary algebra, was plot tables of values. But as you move through intermediate algebra and then into trigonometry and pre-calculus, you gave up on plotting tables of values because you realize that only gives you a small representation of what your graph could be. But with parametrics, like I said, it's forgivable initially. So let's just do this. Time equals -2, -1, 0, 1, and then 2. We'll just stop right there. Let's go through the x values first, because that would be fast. So that'd be -4, -2, 0, 2, and 4. And the y values, again, this would be 4, 5, 6, 7, and 8. It's just plugging into the functions for x and y that you see on the right side of your screen. At this point, we go ahead and plot those values. The deal here is that you're only going to plot the x and y values, even though you have a time value. The neat thing about parametrics, or parametric equations, is that they give you extra information, more information than a Cartesian set or a rectangular set of coordinates would give you, or a rectangular equation would give you. These give you not only x and y values, but a path of travel as time goes on. So let's go ahead and start this out. At time equals -2, I'm going to plot -4, 4. So I'll do this by hand, which means that I could make like some scaling mistakes, but I'll try not to. -4 and up 1, 2, 3, and 4 units. So that looks to be right about here. And that point, you could call it -4, 4. I tend to, when I'm working with parametrics, I tend to do this. I tend to say that's time equals -2. There's nothing wrong with calling it -4, 4 though. Now we're going to go ahead and plot the next point, -2, 5. So back to up 5. Let me go ahead and plot that. Back to up 5. So somewhere around here, that's time equals -1. And then 0, 6. So that's just one up here. There we go. It's time equals 0. And let's see, 2, 7. So let me go ahead and, while I'm at it, 2, 3, and 4. There we go. 2, 7 is probably right around here. Time equals 1. And then the next one was 4, 8. Yeah. 4, 8, I'm going to say is right around here. Slightly scaled incorrectly, I apologize, but that's time equals 2. And you could see that those points exist on a line. Pretty easy to see that. If I scaled it properly, they would exist on a line. And I sort of missed, but that's okay. I'll just make this point somewhat larger. That's the trick in mathematics. If you miss, you just make the point somewhat larger so it looks like you hit. And let's see, what else? So the graph of this parametric set of parametric equations, or in other words, the plane curve or parametric curve that we get, is a line. Not only is it a line, but it's a line with a path of travel. As time moves forward, we use these little arrows to showcase what direction the line is being drawn in. So it gives me an extra piece of information, which is very beautiful. And the punchline is that a parametric equation graph contains more information than a Cartesian graph because plane curves, or parametric curves, indicate a path of travel. This is very, very important as you move forward, because you're going to get curves that look like this, which do not represent functions, right? You can look at this and say, that's not a function of x or y, because it doesn't pass the vertical line test, nor does it pass the horizontal line test. However, this is a function in terms of parametric curves. And so in calculus, you need to know the path of travel because it helps you determine, for example, areas or arc lengths. Well, arc lengths, it doesn't really matter, but areas it does. So there are some very important pieces that you need to know that the path of travel will really help with here. So anyhow, that's an introduction to the concept of what a parametric curve, or what a plane curve is, and what parametric equations are. In the next video, we're going to start graphing parametric curves by hand without plotting a table of values.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.